Okay, first step is what?
Multiply by 2y
Okay, so we
minus
write this out like so. 2y plus 3 over 2y minus 1 multiplied by 2y minus 1, and putting the parentheses around this, so we multiply by the whole thing, equals x minus 3, and even though the x minus 3 doesn't have parentheses here, it needs to have them here because we're multiplying the whole expression, not just the negative 3 or the x by this denominator. So we have to write this out like so. Okay? Then, and I really do want to see you do this step. Where we rearrange this. You know, the numerator is still going to be 2y plus 3 times 2y minus 1. Of course, I need parentheses there, like I just lectured you on here, okay? Right? If I don't put the parentheses here, I'm opening myself to serious error, okay? Because all of this multiplied by this. Again, the numerator would be this times this. The denominator is this, right? Now, down in here, the numerator is this times this. The denominator is this. The numerator is identical to what it was up here, and the denominator is identical, right? Now, if you want to write the 2y minus 1 over 1 and the 2y plus 3 over 1, you could, okay? That can be understood if we understand, if we're aware of how it works. But that's what we've got. And then the 2y minus 1 and the 2y minus 1 give us 1, right? And 1 times this is just this. And that's why we get 2y plus 3. Not because you run lines through this, because, again, I'm still seeing way too much incorrect cancellation. I don't want to see cancellation. Now, if you want to be certified to cancel, I'll give you a whole series of problems. If you can do them without incorrect cancellation, then I'll allow it in your case. But it's got to be an individual thing because, as a whole, we don't understand cancellation very well. Okay, so, and then we use the distributive law up here. And we write out the steps, but I'm not going to write them out because y'all are pretty good at writing out the steps of the distributive law. So I kind of trust you to do that, although I still want you to continue doing it because I really want that to be reinforced. So we're going to get 2xy minus 6y minus x plus 3. Whichever way you choose to write this out, those are the terms that you're going to get. Assuming I did it right. Okay? Now what do we need to do? Well, what we're trying to do is we're trying to test whether this is a linear function in general. Okay? But the way we do that is we solve for y and see if we've got a y equals mx plus b form, right? So what's the next thing we had better do?
Subtract 3 from both sides.
Subtract 3 from both sides? Okay? And that's fine, and that's going to be convenient because you know, you're going to end up without the 3's, okay? But I'm going to do, and there's nothing wrong with that step, okay? And as a matter of fact, let's go ahead and do that, okay? I really don't want to see you write negative 3 here and negative 3 here. People are still doing that. And I really think you need to understand that it's not a magical process, although I think most of you do understand that it is. I want to see things written out like this, okay? Just because the other way is prone to misinterpretation and error, and I have seen errors that come from writing it like that. And then 3 minus 3 is 0, so that leaves us 2y. Now we've got 2xy minus 6y minus x, and 3 minus 3 coincidentally gives us 0. Okay? Okay, so what are we going to do next?
Okay, add 6y. Add 6y to both sides.
Okay? We could add 6y, but what, we're trying to solve for y, right?
Mm-hmm.
If we're trying to solve for y, it really helps to have all the y's on one side, right? Okay? And in the numerator, if we can possibly do that. So I want to do this. I want to say, okay, 2y plus 6y minus 2xy equals 2xy minus 6y minus x plus 6y minus 2xy. Okay?
2y plus 6y minus 2xy.
Now that's going to give us what? 8y minus 2xy. Over here, well, 6y, negative 6y and plus 6y give us 0, right?
What's
And
the reason?
2xy and negative 2xy give us 0, right? So this leaves us just what?
X.
Negative x. Okay, now what are we going to do? Hang on, there's a little noise in the hall. I have trouble. Actually, I should have my hearing aids in, shouldn't I? Okay, I'm sorry, go ahead.
So, what did you just added? I don't get the mirroring.
Well, we're trying to solve for y, okay? And at this point, you've got to understand, and that this is the point where, you know, there's several points where it's easy to make a mistake here, okay, or easy not to see what to do next, okay? But if we have this, then we can write this using the distributive law backwards. We can write y times 8 minus 2x equals negative x, can't we? I mean, check it out. If I multiply this out, don't I get this? Okay? Well, that's your test for whether you factored correctly. We factor out a y, and then we look at this and verify for ourselves that if we multiply through here, we get this. Okay? Because again, if we factor by superstition and don't check ourselves, we perpetuate our superstition, whereas if we check ourselves and see it didn't work, I think in a case like this, would be pretty likely to see where the error is and be less likely to make it in the future, okay? So anyhow, one way or another, we factor the y out, check y times 8 gives us 8y, y times negative 2x gives us negative 2xy, so that's got to be right, okay? And remember, factoring is nothing but the distributive law working in the opposite direction, okay? Then, divide both sides by the 8 minus 2x. And we understand that's just y times 8 minus 2x over 8 minus 2x, which is y times 1. So y is negative x over 8 minus 2x. Okay? Now there's another step of simplification we can do in this. We'll talk about that. We just change the order of the denominator and get rid of that negative there, and it's easy to understand that, but there's enough here to digest that I don't want to talk about that right now. Okay? I mean, that is equal if you want to think about it, to this, but I'm not going to require this step at this point. We'll come back and talk about that. If you get it down to this form, that is a solution. It's not quite in the That's the more simplified form, but for the time being, I'll accept this.
I have a question.